Okay, for my discussion 10 exam review topic, I'll be going over Taylor polynomials. This specific question is from our textbook, chapter 13, section 7, question number 5. I felt this was a good one to review as I struggled with Taylor polynomials for a bit. Until now, I feel very confident in these. One of the reasons I didn't feel too confident a while ago is because I was still struggling with finding partial derivatives, which is needed to solve this problem. After some more practice, I am very confident with my partial derivatives now. And this topic of Taylor polynomials was also covered in Calculus 2. However, I felt that it was very brief and still struggled to understand where these equations came from that we have to know to solve this. And so I went back and looked at my Calc 2 notes, and basically in Calculus 2 we use derivatives to solve this, and here in Calc 3 we're using partial derivatives. So let's get started. Our first step will be to find a series of partials. So here's our original function, x squared y plus y squared. We will now find fx xy, which will be 2xy, f of y xy will be x squared plus 2y. Now fxx will be 2y. Fyy will be just 2, as it comes from this function. And fxy, looking at fx first, that would be 2x. There's our partials. Now we will plug it into our given point of 1, 3. So we have f1, 3 is equal to 12. fx 3 equal to 6. Fy 1 squared plus 2 times 3, which equals 7. fxx 1, 3 equals 2 times 3, which is 6. Fyy is already constant, so that will stay the same. And lastly, fxy at our point equals 2 times 1, which is equal to 2. So now we have our values for our partials, which we will now need for our equation. So we are finding Lxy and Qxy. In order to find Qxy, we do need to know Lxy. So we will start with the linear approximation. Our equation to find that is Lxy equals f of xy plus fx xy times x minus our x value in our point plus fy x comma y times y minus our y value in our point. So let's plug in these points. x minus 1, as that's our x coordinate, plus, and our y coordinate is 3. All right, f(1,3), we solve for 12 plus fx1 comma 3 is 6 times x minus 1 plus fy is 7 times y minus 3. Simplify this out. This will equal 6x plus 7y minus 15. So there's the first part there we need to solve for, the first degree Taylor polynomial. Now we will solve for our quadratic approximation. Q x comma y. Now this is a little longer equation. This is Lx y plus fxx over 2 times x minus our x coordinate squared plus fxy times x minus our x coordinate times y minus our y coordinate plus fyy over 2 y minus y, our y coordinate squared. Okay, now we can solve. We know Lx will be 6x plus 7y minus 15 plus fxx 1 comma 3 over 2 x minus 1 squared plus fxy 1 comma 3 x minus 1 y minus 3 plus fyy 1 comma 3 over 2 y minus 3 squared. So let's plug in and simplify. 6x plus 7y minus 15. fxx 1, 3 is 6. Divided by 2 will be 3 times this, which is x squared minus 2x plus 1 plus fxy is 2 times, simplify x minus 1 times y minus 3, xy minus 3x minus y plus 3 plus fyy is 2 divided by 2, which is 1, times y squared minus 6x plus 9. Six x plus 7y minus 15 plus 3x squared minus 6x plus 3 plus 2xy minus 6x minus 2y plus 6 plus y squared minus 6x plus 9. And now we can simplify this a little more. These two we can see will cancel out. And this is actually a y. My apologies. So we have 3x squared plus y squared plus 2xy minus 6x. We have a 7y minus 2y is 5y minus 6y is minus y, and negative 15 plus 3 is negative 12 plus 6 is negative 6 plus 9 will be plus 3. And that will be our answer. That is how we solve for first and second degree Taylor polynomials. Under the link to this video will also be a visual through Calcplot 3D of our original function, the point we were given, and these two functions, and showing how they are tangent to this function at the point 1, 3. Thank you very much.